Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 3.1 parallel lines cut by a transversal. I love this lesson.
Do you?
I do, because
It's
so, once you really understand it, it's just very much, it's there, it's done, there's not much to it.
Yeah.
Okay, so what we are doing, by the end of the lesson, I will be able to identify which angles are congruent and which angles are supplementary when parallel lines are cut by a transversal. Why do we have to learn this? Well, knowing the angle relationships and understanding them, it sets up a foundation for triangle and quadrilateral theorems. Like we have explained in the past, understanding triangles, there's so much geometry around triangles. I guess that's why we have
trigonometry,
we have a whole entire course of trigonometry. Yes, absolutely. So how will you know you understand it? Well, you'll know you have mastered it when you can set up an equation correctly to find angle measurement. I promise you, this is not a tough lesson, and it should be pretty easy even for our students who define themselves as mathematically challenged.
All right, well, let's go ahead and get started. So the first thing, we gave you a big picture of line A, B, and C. Go ahead and number your angles as we have them on here. There's some critical information about these that we want to discuss with you guys. All right, so the first, if you need to pause to fill in your numbers, go ahead, is the fact that we have angles that are between lines A and B. So right here in this range that you can see here, those are all considered to be interior angles.
It almost looks like the meat and the cheese and everything between slices of bread. Yeah, it's the meat.
So if angles 3, 4, 5, and 6 are considered interior, then the ones that are not interior would be considered exterior. So angles 1, 2, 7, and 8 are exterior angles.
This is your bread. It holds it all together.
Line C, if you look, this is going to be a vocabulary word. Line C, you can see, is intersecting both lines A and B. This is called a transversal, when you have a line intersecting two or more lines. And then the last thing I want to talk about is how we have kind of two clusters of angles. So up here we have angles 1, 2, 3, and 4, all using this vertex right in the middle here. Whoops, I hit the transversal again. Make that bigger, sorry about that. So we have angles 1, 2, 3, and 4 that I like to call them as a cluster. They're all using the same vertex.
Did you know they have identical twins?
Do they?
They do.
Well, let's look down here and see. So right down here we have a second cluster, 5, 6, 7, and 8. And as Miss Net said, these are kind of like twins. You have two sets of clusters that are identical to each other.
The other thing I want everyone to notice here, with parallel lines cut by a transversal, so many students get caught up in this is so difficult, but in reality, you're only dealing with two different types of angles. Either it's a small angle or a relatively small angle or a big angle. And all of your angles are either small or big. Once you know the measure of the big angle, all the big angles in the picture, so for example in this picture, angle 1, angle 4, angle 5, and angle 8, they're all big.
Mm-hmm.
They're all the same.
If the lines are parallel.
If the lines are parallel. Absolutely.
The picture I'm giving you we can say that line A and B are parallel, so what Miss Net said would be exactly right.
So angle 2, angle 3, angle 6, angle 7, they're all small. Here's the crazy thing. Once you know the measure of angle 2, that means you now know the measure of angle 3, angle 6, and angle 7, because they are all the same.
So there you go. So while there's 8 angles up here on the board or on your screen right now, there's actually only 2 angles.
You ready for this? Angle 2 and angle 3 are vertical angles.
So a little review from lesson 1.2. I'll give you another one. Angle 6 and 8 are a linear pair.
Shut up, this is crazy. So we can use all of that math that we have learned in previous lessons to help make this lesson in chapter 3 easier. So we have linear pairs, we have vertical angles. This is going to be so easy.
So let's go look at some more angle relationships. So we just talked about how angle 2 and 3 are vertical, angle 1 and 4 are also vertical, angle 7 and 8 are also a linear pair. Let's learn some new relationships. The first one's going to be corresponding angles, which is under your congruent box. This is going to be the first box we're going to talk about. So if you want to draw a little tiny picture, I'm going to have you write some things in this box as well. If you want to just draw a little tiny picture of what I have drawn here for you guys, that is showing a pair of corresponding angles.
A silly way that I use to remember corresponding is that it has two R's, C-O-R-R. The R's, they're identical.
There you go. That's one way to remember it.
And now you'll understand that when you have the corresponding angles are identical pairs.
We also talked about the word corresponding back in lesson 2.1 when we were talking about two congruent shapes. All the parts that were in corresponding places were the same. So remember, corresponding means in the same place. So the picture I'm showing, you can see that the angle right here, the angle right here is in the same place of the intersection as this one. So that is showing one of the pairs of corresponding angles. It's angles in the same place with respect to the vertex. So now, you should have drawn this little picture. Now I'm going to have you list, using the picture above, all of the corresponding angle pairs. We know that they are congruent to each other. So, like for example, the first pair would be angles 1 and 5. We could say 1 and 5 are congruent because they are corresponding angles. 2 and 6 are in the same place, so therefore they are corresponding angles.
Notice that they are both in the exact same position for each cluster. So if you'll notice, angle 2 is in the upper right, angle 6 is also in the upper right. If you'll notice, angle 1 is upper left and angle 5 is in the upper left.
Angle 3 and 7 are both lower left, and angle 4 and 8 are both lower right. So those are all your pairs of corresponding angles. If, and according to your notes, you have that the lines are parallel, and we already talked about how we are going to use that A and B are parallel, we can say those four congruence statements. All right, your next pair of congruent angles are going to be alternate interior angles. So you can go ahead and draw a small picture showing one of the pairs. There are actually two pairs of alternate interior angles. These are going to be angles in, they are not on the same side of the transversal, and they are between the two lines.
So they're on the inside of the sandwich, but on the opposite sides of like a knife cutting through the sandwich.
Right. That word not should not be there. That's why I froze. Angles not on the same side of the transversal and angles in between the two lines. So if we look at our diagram above, we can see that angles 3, 4, 5, and 6, remember, are interior. They're in between lines A and B. Now let's look at those four angles and decide which ones are not on the same side of line C, the transversal.
Well, if you look at angle 3 and angle 6, they are separated by the yellow transversal line. So 3 and 6 are on opposite sides of the transversal.
Same with angles 4 and 5. So because the lines are parallel, we are able to make these two congruent statements, that angle 3 and 6 are congruent and angle 4 and 5 are congruent.
Excellent.
All right, now the last pair of congruent angles that we will discuss are going to be alternate exterior angles. Go ahead and draw the small diagram.
So these are on the outside, or basically kind of like on the bread, so to speak. And because they are on the outside and they're on opposite sides of the transversal, they are also congruent.
So let's go ahead and look at the diagram above. We could say that angle 1, 2, 7, and 8 are all considered to be exterior angles. So now let's look at which ones are split apart by the transversal. So 1 and 8 are being split apart. And then the same with 2 and 7. So we can say 2 is congruent to 7 and 1 is congruent to 8 because they are alternate exterior angles.
Awesome.
So now let's discuss the supplementary pairs. There are 2 sets.
Let's talk about supplementary. Supplementary means that they will come together and equal
180 degrees.
So, for those of you still struggling with this, let's remember supplementary is like a supper table, and a supper table where we eat our dinner is a flat surface, which is 180 degrees. So, supplementary 180, get it in your head.
So I went ahead and gave a small diagram, well mine's big, but you can draw a small one, of a pair of same side interior angles, because to be same side, they have to be angles on the same side of the transversal and have to be between the 2 lines. So you can see my example here. This one here and this one here are both on the right side of the transversal, and they are both between the pairs of lines.
So if you go back to what I said at the very beginning of the lesson, where you'll only really have 2 measures of angles, small and big, also to note, the small and the big will always, always, always add up to 180 degrees.
So that's another piece of the puzzle that is going to make this lesson very easy. They're either the same or they add up to 180. So let's go ahead and look at the diagram up at the top. If we say 1, 2, 7, and 8 are exterior, so therefore 3, 4, 5, and 6 are interior. Now we're going to look at those 4 angles that are interior, but on the same side of line C are transversal. So 3 and 5 would be on the same side, and 6 and 4 would be on the same side. So we are able to say that those pairs are supplementary because they are same side interior angles. And then the last pair, we have our same side exterior. There's your diagram. It's going to be the exact same thing we've talked about in the prior 4. We have exterior angles, so they are not between the lines, and then they have to be on the same side of the transversal.
So your same side interior and your same side exterior, there's no difference.
Just, are they between the lines or are they not? So here's our diagram up at the top. We could say that angle 1 and angle 7 are supplementary, and we can say that angle 2 and 8 are supplementary because they are same side exterior angles.
Excellent. Let's
All right,
do some
so now
math.
let's do some equation solving. So we have a diagram, and we're told that line A is parallel to B. We need you guys to change the given information so that it matches the picture. Sorry about that. We have that angle 1 is equal to 11x minus 8, and we have that angle 2 is equal to 8x minus 2. So if you have that already, you're good. If you don't, please make your notes reflect what you see on the screen right now. All right, so looking at this, we can see that angle 1 and angle 2 are definitely interior angles. If they are interior, then they are either same side or alternate.
So wait a minute. Do we have a small angle and a big angle?
We do. So
Wait.
that must mean
that my small angle and my big angle, because all the small angles are identical, all the big angles are identical, and in the previous slide, we said any small angle plus a big angle is 180 degrees.
Right. So we know that these are supplementary, which means we know that they add up to 180. So I broke that up so that you can see that. Our equation, we're going to substitute in what angle 1 and 2 actually equal, and you end up getting the equation where you're adding the 8x minus 2 and the 11x minus 8 together to equal 180. Do they have to write all of that?
Well, I would say sometimes yes, sometimes no. I mean, it depends on kind of where you're at.
I would say in your notes, I would make
in your notes,
write as much of this as you can. I know you don't have a ton of room. Use abbreviations, but this is going to help you understand how the equations are made.
In your notes, I would absolutely say 100% yes, absolutely. You must write all this because all of this is going to help you when we get to writing proofs. Because really, all we are doing is we are saying what we are doing and why we are doing it, which is a proof.
Right, and you're going to work through problems logically. So in looking at our equation that we've created, what would be the next logical step? Combining like terms. So 8x plus 11x would be 19x. And then the negative 2 and negative 8 make negative 10. Your next logical step would be to add 10 to both sides.
Let me guess, the addition property of equality?
Correct.
No way!
Way. And then the last step to find x would be to use the division property by dividing 19 into 190. That gives me a value of 10 for x.
In the words of a little Z, boy!
Boy. All right. So now the question is asking us to find the measure of an acute angle.
Wait, acute. I think we need to review a word.
So an acute angle is an angle that measures less than 90 degrees. So if I were to take my 10 that I just found and plug it into the 11x minus 8 and into the 8x minus 2, I would get two angle measures that are 78 and 102. One of those is acute.
Acute. Well, I kind of think of acute as being something cute and tiny, so I'm going to go less than 90.
Less than 90, which in this case is angle 2. Angle 2 is 78 degrees, and that is our acute angle.
I think I'm getting the hang of this. Can we try another one?
We can. Why don't you guys go ahead and pause the video and see if you can solve this one the same way that we solved the previous one.
Now, if the fraction 3/4 is scaring you, I want to absolutely recommend putting away your calculator, because the only way to get over your fear of fractions is to learn them.
Yep. All right, so you should have paused the video and worked this out. Hopefully that is what you did. Looking at angle 3 and 7, where they are located on our graph, here's 3, here is 7, you should have identified that those are going to be congruent because parallel lines make congruent alternate interior angles.
So since they're congruent, can I say that one is equal to the other?
You can, because that is what the definition of congruence is. And then we can use substitution, and we get the equation x minus 4 is equal to 3/4 x. Again, as Miss Net said, don't be scared. This is not a difficult fraction to work with. You would simply have to move the x over to the 3/4 x using the subtraction property. 3/4 minus 1 would be 3/4 minus 4 over 4. 3 minus 4 gives you negative 1 as your numerator.
Easy, easy.
Your last step for solving for x would be to get rid of that negative 1/4. To do that, you would have to multiply to both sides of your equation, giving you a value of 16 for x. Now the question is asking you to find the measure of angle 6. Well, angle 6 is neither of the angles we worked with, but we need to go back to what Miss Net said at the beginning. You either have big angles, small angles. If you have one of each, you know they add up to 180. So if you look here, you know angle 3 and 7 are the same. 6 is not the same size. You can see that clearly from the diagram. So what you need to remember then is if you can find angle 3 or 7, you know you would have to subtract your answer from 180 because the different angles add up to 180, small and big. So that's what you're going to do. You would simply say that angle 6 and 3 are supplementary, is how I did it because of linear pairs being supplementary. If angle 3 is equal to 12, and I got that by plugging in my 16 to the x minus 4, 16 minus 4 is 12, you would then be able to get angle 6 is 168 because 168 is the supplement of 12. And that's it.
Yay! Let's do another one.
The last two problems we're actually going to be writing proofs. Yay!
And we're going to show you just how easy they are.
We are always going to keep these easy. I always want you to try your very best to pick one angle that proves what you're trying to prove. In this problem, we are trying to prove that 1 is congruent to 8. Yes, I know angle 1 and 8 are alternate exterior angles, and we just told you that they are congruent, but we want to know, why is that a thing? Why do alternate exterior angles always equal each other? Why does that work?
Okay, so first, always start out with your given. So the given is always going to be step 1. Please don't forget that. That's an easy point.
That is a very easy point. The next thing you have to do is think about, well, if I need to know that angle 1 and 8 are the same, are angle 1 and 8 the same as something else that we know? Well, we've already talked about how all the big ones are the same, all the little ones are the same. It's just a matter of now linking them together like the chain rule. So your hint is transitive property, which, if you remember, was very similar to the chain rule.
Or syllogism.
I am going to use angle 5. You could also use angle 4, would be another way you could do this.
But we're going to go ahead and use angle 5 for right now.
So my first statement that I can make would be connecting angle 1 and 5. What do you know about angle 1 and angle 5?
Well, angle 1 and angle 5 look to be kind of like identical in those cluster things you were talking about.
So we know that they are congruent, and that cluster, when we used it, it was that parallel lines create congruent corresponding angles. I have in capital letters CAT, this is the corresponding angle theorem. So now that you've linked angle 1 with angle 5, let's see if we can link angle 5 with 8. What do we know about angle 5 and angle 8? Well, looking at the picture, they're opposite an intersection point from each other. So we know that they are congruent because they are vertical. Vertical angles make congruent angles. VAT in capital letters, this is the vertical angle theorem that I'm explaining in my reason. So now what we've done is we have proved that angle 1 is congruent to angle 5 and angle 5 is congruent to angle 8. So if I know both 1 and 8 are congruent to the same thing, angle 5, what can we then say about angle 1 and 8? That they are congruent, and that is the transitive property. And that is your first, I think, official proof. Congratulations, everybody.
Let's do another one.
We have one more to do, and then we are done. We're going to prove that the lines are parallel. So if you remember, all the things we had you write on the front of your notes today with alternate interior, same side exterior, all of those relationships have to be true if the lines are parallel. So what that means is that in this particular problem, we are not allowed to use any of those relationships because we don't know the lines are parallel. That's what we're trying to prove. Now, the nice thing is we could prove the converse of any of those relationships.
Converse, wait, that's if you flip your if and your then.
Correct. So if we can get congruent alternate interior angles through other means, we then have parallel lines. Or if I can prove that I have supplementary same-side interior angles through other means, we are then able to say the lines are parallel. That is the converse of those relationships. So the relationship I have, the only thing that I know for sure that's given to me is that 4 and 7 are supplementary. So we have to pick an angle that I am able to connect these two. So I used angle 1. So looking here, what do I know about angle 1 and 4?
Well, they look to be kind of vertical to me.
So because they're vertical, we can say they are congruent because vertical angles are always congruent. That is the vertical angle theorem. That is making the connection between angles 1 and 4. Now we need to make the connection between 1 and 7. Well, what do we know about angle 1 and 7? We don't know anything. However, I know angle 1 and 4 are the same, and I know angle 4 and 7 are supplementary. So,
wait, so couldn't then, if 1 and 4 are identical, couldn't I use 1, or sorry, yes, couldn't I use 1 anywhere there is a 4?
I could. So, would it be the same thing saying 4 and 7 are supplementary? Could I now say angle 1 and 7 are supplementary?
Well, if 4 and 1 are identical, yeah.
That's going to be our next step. That is our substitution property. You are able to plug angle 1 in the place of 4. And why that's important? Through other means, notice I have not used the word same side exterior angles at all. But look what I've proved. I've proved that I have supplementary same-side interior angles. If you remember, I said if they're supplementary, that means you had to have had parallel lines. So because I've proven that they are supplementary, I have that they are parallel. The reason, if you have supplementary same side exterior angles, you have parallel lines. That is the converse of the same side exterior angle theorem.
This is so easy. This is nowhere near as bad as I thought it was going to
It
be.
really is not. And the one thing I do want to mention, these are just two ways for these two proofs. This particular proof I could have done any number of ways. Why I picked angle 1, I picked it randomly. Okay, so that's an important thing I need you guys to understand. Don't get caught up about doing it the same way as me and Mrs. Netz. There is usually a number of different ways. When you have all 8 angles to work with, you could probably prove this using any of the 8 angles. You just have to use angle 4 and 7 because it was part of your given. Any angles part of your given and your proof statements must be used. Then you can use any of the other ones to help support your reasoning.
You ready for this? If you've taken this class in the past from either Mrs. Weichel or myself, you will have seen we did this exact same lesson using a different proof.
Yes, we like to change it up every semester. So there you go. There is your lesson on parallel lines. Hopefully you guys feel good about same side interior exterior, alternate interior exterior, and lastly your corresponding angles that are in the same place of your clusters. That is the conclusion of 3-1. Hopefully if you have any questions you will reach out to Miss Netz or myself or your teacher through Remind or email.
Hey, Mrs. Weichel.
Hey, what, Miss Netz?
This is a very sad ending.
Oh.
It is.
Boo.
Much like many of the high school love stories that we hear about. Have you heard about the parallel lines?
I have not.
It's so sad because
am I gonna cry?
maybe they're so similar. They're very, very much alike, but
so they're made for each other.
They are,
I
but
think
they will never meet.
They're never gonna. Oh, because they're parallel.
Yeah.
Thank you for joining us. We will see you or talk to you in 3.2.
Great.